Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to configure YOLO4 tiny version on our Raspberry OS Bullseye 64-bit version. We are going to create a custom model for YOLO4 tiny. Okay, so before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, we are going to configure YOLO4 tiny on Raspberry OS Bullseye 64-bit version. Means we are going to create our custom model for YOLO4 tiny. Simple. So for that, first you need to install latest opencv on Raspberry OS Bullseye 64-bit version. I will mention video link. Watch video and install opencv on Raspberry OS Bullseye 64-bit version. Okay, then for today's session I have created here a repository. A repository name is YOLO4 tiny rpy4. I will mention the link inside my description box. Copy and paste link inside the browser, then go to the code, copy the link from here, copy it, and we are going to simply clone our repository. So run the command git space clone and just paste a link of our repository. Just hit enter. It will clone our repository. Okay, so now we have our repository. Now first thing first, what we want to do, we are going to train our images. So we need here label EMG software. Okay, so for that we are going to open our repository. So our repository is YOLO4 tiny rpy4. Okay, and inside that, as you can see, I have created here a text file, and the text file name is label emg install.txt. so right click text editor, and we have here two commands. So we need to simply copy paste these two commands inside our terminal. So first command, copy, open terminal, and let me first clear the screen, and then simply we are going to paste our first command. Just hit enter. It will install pyqt5-devtools on our Raspberry OS Bullseye 64-bit version. Then our second command, which is label emg software. So copy the second command, paste inside the terminal, and then just hit enter. That's it. We are done with label emg software. I have already installed both packages. Okay, that's why it says the requirement is already satisfied. So this is how you need to install these packages. Simple. Now what we want to do, we need our data. Okay, so we are going to use here our USB web camera for our data, or we can say for our images. Okay, so in this session we are going to detect basically Arduino ID, then rpy pico, then mask image and without mask image. Okay, so simple. So for capturing images, I have created here img.py script, which basically create images, okay, with the help of our USB web camera. Of course you can use your Raspberry Pi 4 camera module also. So just right click img.py and click on Thony Python ID. It will open our img.py with the help of our Thony Python ID. As you can see, it's open. So it's creating 70 image for each class. Means if I want to detect the Arduino, so it will create Arduino 70 images, then pico 70 images, then without mask images 70, also with mask 70 images. So this is the frames, maximum frames. Okay, you can simply increase as per your requirement. You can mention 170, you can mention 200. If you want to go with more data, you can mention 1000 also. Okay, so we are going to train only 70 images per class. Okay, right now, simple. So first we are going to start with Arduino. So here what we want to do, it will create the images inside YOLO4-tiny and obj folder. So we need to create this folder. Okay, so first what we want to do, open again file manager, and here we are going to create YOLO4 tiny folder. Okay, so YOLO4-tiny. so open, and I am now inside /home/pi. As you can see, /home/pi. So here right click, new folder, YOLO4-tiny. Click on OK. Okay, YOLO4-tiny, we have here our folder. Okay, and inside that we are going to create again new folder, which is obj. So just right click and again create new folder, which is obj. Or nothing to create inside basically YOLO4-tiny. We are going to simply create outside, okay, obj, not inside YOLO4-tiny. So just click here and create a new folder. There is no need to create, again I am going to explain here, there is no need to create obj folder inside YOLO4 tiny folder, because we want to save a zip format file. Okay, so just create obj folder inside /home/pi, not inside YOLO4 tiny. Okay, when we capture our data, then we are going to train our data, or we can say we are going to basically create the rectangle on our data, and then we are going to create a zip file obj.zip, and the zip file which we want to save inside YOLO4 tiny. Okay, there is no need to create a obj folder inside YOLO4 tiny. That's it. So we have created here a two folder, YOLO4 tiny. Okay, right now there is nothing. Okay, and then we create a obj folder. So inside obj folder we are going to save all our data. Okay, so here what I am going to do, I am going to change this YOLO4 tiny. Basically I am going to remove YOLO4 tiny. So we need to mention the path. Okay, so /home/pi obj is our folder inside /home/pi, and then we are going to save our images. Simple. So let's just start with Arduino. So I need to delete without mask, and here we are going to create our first class. So Arduino, which is our class name, Arduino. Okay, so this is what our class name. Okay, simple. So let's just save the code, and we are ready. Now I'm going to simply start web camera. Then we are going to simply move our Arduino board in front of USB camera in different angle. Okay, so simple. So I'm going to start our web camera. Okay, so friends, as you can see, we have created a data for Arduino. So if I open our obj folder, and inside that, as you can see, we have 70 images for Arduino. Okay, now same way we are going to create another 70 images for Pico board. So let's just change our class name with Pico. Okay, so save the code, and now I am going to start again code, and it will capture our 70 images with Pico board. Okay, so friends, we have successfully captured our Pico board image. Now with mask, so with mask, okay, with face mask. Okay, so with mask we are going to capture again 70 images. Okay, so save the code, and if I run the code, so friends, we are done with mask. Now without mask, so without mask, this one is our last class. Okay, so again save the code, and if I run the code, so friends, as you can see, we have successfully captured our images. Okay, now what we want to do, we want to draw a rectangle on our classes. So we are going to simply close our Tony Python ID and just open terminal, and we are going to run our label EMG software. So run the command like this way, label, and just press tab button. It will auto complete our command. As you can see, label EMG, just hit enter, and as you can see, we have our label EMG software. So click on open dir, click on open dir, and our dir is obj. So select it, click on choose, and it will open our images. As you can see, then change save dir and same dir obj, just click on choose. That's it. Now here we need to select YOLO, then create rectangle box, and we are going to simply draw a rectangle box on our Arduino, and label EMG we are going to mention the class name Arduino. Click on OK, save, next image, create rectangle box, draw the rectangle box on our object, click on OK, save, next image, create rectangle box, draw rectangle box, click on OK, save image. Okay, so now let me train Arduino images. Okay, then I will start a video. Okay. So friends, we are done with our Arduino. Now this is what our Pico board. So again click on create rectangle box, and we are going to draw a rectangle box on our Pico board, and the label we are going to mention Pico. Simple. Click on OK, save, next image, create rectangle box, again draw the rectangle box on Pico, click on OK, save, next image, create rectangle box, draw rectangle on Pico board, and save. So now I am going to train all our Pico images. Okay, So friends, we have done with pico board. Now mask image. Okay, so with mask, so create rectangle box and we are going to draw a rectangle on our mask and we are going to say like this way, with mask. Okay, with hyphen mask, click on OK, save image, next image, create rectangle box. Again we are going to draw a rectangle box on our mask, click on OK, save, next image. Okay, so this is how I am going to train, or we can say this is how I am going to draw a rectangle on our with mask images. Okay, so friends, we have done with mask images. Now we are going to draw a rectangle box on our without mask images. So create rectangle box and we are going to make like this way, without mask. So here we are going to mention without mask. Okay, click on OK, save, next image, create rectangle box, without mask, click on OK, save, next image, create rectangle box, again without mask, click on OK, save rectangle box. So this is how I am going to train our last image, which is without mask. Okay, so friends, we have successfully trained our all images. Now simply we are going to close our label AMG software. Now what we want to do, if I open file manager, and this is what our obj folder, and inside that we have our images and their text file. Okay, simply what we want to do, we want to create a zip file for our obj folder. Okay, so what we are going to do, if I run over here ls command, so this is what our obj folder, and we have our obj folder inside /home/pi. Okay, so run the command like this way. Let me first clear the screen. Zip hyphen small r, then the zip file name, so obj.zip, and the folder name obj/star. It will create a zip content which we have inside our obj folder. Okay, so zip space hyphen small r space obj.zip, this is what our file name, and then space obj/star. Just hit enter. As you can see, it's creating a zip file with the data which we have inside our obj folder. So if I open our file manager, just a minute. Okay, so here it is. As you can see, we have here obj.zip file. So simply what we want to do, we create here YOLO4 tiny folder. Okay, and right now there is nothing, so we want to simply move this obj.zip. Just click cut inside our YOLO4 tiny, paste. That's it. Now friends, what is the next step? We have here our repository which we just cloned. So our repository name is YOLO4 tiny rpi4. Okay, and inside that we have obj data, obj names, and YOLO4 hyphen tiny custom.cfg file. Okay, so right click obj data, text editor, and here it is. As you can see, by default the classes is 4 because I have right now 4 classes. Suppose if you have 2 classes, you need to mention here 2 classes. If you have 10 classes, you need to mention here 10 classes, not 2, basically 10 classes. Okay, so classes is basically how many classes you have, means how many objects which you want to detect or which you basically train. Okay, so this is the things which you want to change here only. Okay, so classes is equal to 4 because I have here only 4 objects. Okay, 4 classes. So classes 4, just click on file and click on save. That's it, simple. We are done with obj data. Okay, then obj names, right click, text editor. Okay, and here inside that we need to mention our classes names. So as you can see, I have mentioned the 4 classes. First one is Arduino, second one is Pico, and another one is with marks, and last one is without mask. Okay, so this is how you need to mention your classes name, or you can say your object names. Okay, which inside obj.names file. That's it. So we have done with obj data, we have done with obj names, then YOLO4 hyphen tiny custom.cfg file. Okay, so right click, open with text editor, and here what we want to do, just scroll down. Okay, and at the end, as you can see, YOLO at the end, YOLO. Okay, and here the classes, of course you need to mention your classes numbers. Okay, so I have here 4 classes, so I have mentioned here, as you can see, the number is 4. Suppose if you have 2 classes, so you need to mention 2 classes. So right now we have here 4 classes, so I have mentioned 4 classes. Then what we want to do, the filters, as you can see, this is what our YOLO. Let me make like this way. I'm going to close with text editor, just save it, and right click YOLO for custom CFG, and we have here, I think it will open with, okay, so we have here numbers, so it will get better idea. Okay, so what we want to do, just scroll down, and here as you can see, 270 line. Okay, 270 line, we have classes. So here you need to mention your classes numbers. If you have 10 classes, you need to mention 10. If you have 2 classes, you need to mention 2. Okay, so right now I have here 4 classes, so I have mentioned 4 classes. Then here, as you can see, the filters. So filters I have mentioned 27. So how to mention filters? Okay, so if I scroll up, here it is, as you can see, I have mentioned the method for mentioning, or we can say for creating the filter. So filters is basically classes, the number of classes which we have, plus 5 multiplied by 3. Means right now I have 4 classes. Okay, so 4 plus 5 multiplied by 3, 27. That's why I have mentioned here, if I scroll down, that's why I have mentioned here in filters, I have mentioned, where is filters, this, not this one basically, okay, not this one, YOLO, and here it is, as you can see, this one is YOLO. At the line 264, as you can see, at the line 264 filters, here you need to mention the number 27. Okay, with this method, the classes, suppose if you have 2 classes, so 2 plus 5 multiply by 3, then you need to mention here 21. Okay, so then here's, as you can see, right now I have 4 classes, so 4 plus 5, then multiply by 3, it's become 27. Okay, so I have mentioned 27. So here also, if I scroll up, one more thing, there is, here it is also, we have filters, as you can see, line number 213 filters 27. So line number 213, then the line number 264 filters, and then line number 270. Here you need to mention classes numbers. Okay, so I have mentioned here method. Again I am going to explain here. Classes, how many classes, then plus 5 multiply by 3, then whatever the number you need to mention with filters. Simple. So this is how you need to mention changes inside YOLO4 hyphen tiny custom CFG file. Simple. So I am going to close all these things, and we have done with changes. Now what we want to do, we want to move this obj data, obj names, process.py and YOLO4 hyphen tiny CFG file inside our YOLO4 hyphen tiny folder. Okay, so we are going to copy and then YOLO4 hyphen tiny, just paste where we have our images, means obj.zip file. Inside that we have our all train images. Okay, so then again our repository, obj.names, copy, go to the home, YOLO4 hyphen tiny, paste. Again go to the home, our repository, then process.py, copy, go to the home, tiny, YOLO4 hyphen tiny, and paste. Then again go to the home, same process, then this time custom CFG, so copy it, home, and YOLO4 hyphen tiny, just paste. Okay, so now we have here obj data, obj names, our images with zip, obj.zip, then processes.py and YOLO4 hyphen tiny custom.cfg file. So we have done. Now what we want to do, we want to simply move our YOLO4 hyphen tiny inside our Google Drive. So open Google Drive, and here I am going to click here and click on folder upload, then YOLO4 hyphen tiny, as you can see, click on upload. So it will upload our folder. So here just click on upload. Now meanwhile what we are going to do, we are going to simply open our Google Colab. Okay, so click on Google Colab. So friends, as you can see, I have opened Google Colab, click on upload, choose file, and our Google Colab file is in our repository YOLO4 tiny archive 4. This is what our repository, and inside that, as you can see, we have our Colab file. So click on open. So it's now uploading. Okay, so meanwhile what we want to do, open again our Google Drive, and we have successfully uploaded our folder yolov4-tiny. Click on the folder. Okay, and this is what our data, our files, as you can see, yolov4-tiny-custom.cfg, then process.py, then this is what our data, obj.zip, obj.names, and obj.data. So we are now inside yolov4-tiny. So here what we want to do, we want to create a new folder. So right click and click on new folder, and here we are going to create a new folder, and the folder name is basically training. Okay, just click on create. So as you can see, we create a new folder inside our yolov4-tiny. So if I go my drive, yolov4-tiny, and inside that we have training folder. That's it. Now what we want to do, we want to go on our Google Colab files, then click on runtime type, change runtime type, select GPU, click on save, and then click on connect. Okay, now it's connecting. Okay, just click on OK. Notebook requires high RAM, click on OK. So friends, we have successfully connect. Now just start with first code. It will clone the darknet folder. As you can see, we have successfully cloned our darknet folder. Now we want to mount our Google Drive. So click on here, second code, then connect to Google Drive. We want to permit this notebook to access your Google Drive. So click on connect to Google Drive, then choose your Gmail ID, then scroll down, then click on allow. Okay, as you can see, it's now mounting our Google Drive. So friends, we have successfully mount our Google Drive. Then our next code, which is third code, make changes in the make file. So just click on here, done with third code. Now fourth code, it will build our darknet. As you can see, run make command to build darknet. Okay, so it will take some time. So friends, we have done. Okay, as you can see, build darknet process completed. So just scroll down, and we are going to run our fifth code. So click on here, done. Then now it will unzip our data. So click on here, copy the dataset zip file to the root darknet folder, and it will unzip our data. As you can see, it's unzipping. Okay, we have our all images. Okay, now scroll down. Now copy the custom CFG file from the drive to the darknet CFG folder. So click on here. So next code, copy the obj names and obj data files so that they are now in darknet and data folder. Okay, so just run the code. Now same way, process.py, it will copy inside the darknet folder. Run the code, done. Now we are going to run our process.py. So click on here, done. Now we need a yolov4-tiny pre-trained weights. So just click here, it will download our yolov4-tiny pre-trained weights. Okay, so we have done. Now what we want to do, we are going to simply start our training. Okay, as you can see, train your custom detector. So just click here. So friends, as you can see, our process is started. Okay, so it will take some time. Meanwhile, I will pause video. Okay, so friends, our process is still going, but if you go inside our Google Drive, and we have here our training folder. Okay, and now as you can see, inside training folder we have here 3 weights file: yolov4-tiny custom last weight, then yolov4-tiny custom best weight, and the last one is, as you can see, yolov4-tiny custom 1000 weights. Okay, if you want to stop the training, you can simply stop the training. So if you want to go with more iterations, you can simply continue, or if you want to just go with a 1000 dot weight, means we completed here 1000 iterations. Okay, so you can simply go with this weight. Okay, yolov4-tiny custom 1000 weights. Okay, so simply what I am going to do, I am going to simply stop our code. Okay, because we have our weights file. So simply just I am going to close the Google Colab. Okay, and now what we are going to do, we are going to simply download our 1000 weights. As you can see, this is what our weights file when we completed our 1000 iterations. Okay, so simply just right click and just download, and now our file will be download. Okay, as you can see, it's now downloading YOLO4 tiny weights 1000 dot weights basically. Okay, so it's downloading. So if I go here, click on show in folder, and as you can see, this is what our file inside downloads. Now what we want to do, we want to simply copy our weights file, go to the home, and where we have our repository, we have our repository inside /home/pi YOLO4 tiny rpi4. This is what our repository. Just paste our weights file inside our repository. That's it. Now I have already created the Python script for detecting the objects, our custom objects with our weights file. Okay, so for that, first what we are going to do, we need here TensorFlow main version and cvlib package. Okay, so simply we are going to open our terminal. Let me clear the screen. Okay, and we are going to install first TensorFlow. Okay, TensorFlow main version, not TensorFlow Lite. Okay, sudo pip3 install TensorFlow, and just hit enter. It will install TensorFlow on our Raspberry OS Bullseye 64-bit version. I have already installed. Okay, that's why it says the requirement is already satisfied. Then as I mentioned, we need here a cvlib. Okay, so run the command sudo pip3 install cvlib and just hit enter. Okay, it will install cvlib on our Raspberry OS Bullseye 64-bit version, which also I have already installed. That's why it say requirement is already satisfied. So we need here TensorFlow main version and cvlib package. Okay, simple. So we have done. Now we are going to simply open our file. Okay, so our file is basically test.py. as you can see inside our repository test.py. so right click Thony Python ID, and it will open our test.py inside our Thony Python ID. Okay, and as you can see, from cvlib.object detection import YOLO, then import cv2. Okay, then cap is equal to cv2.video capture. This is how we always call our web camera. Okay, so then weights. So weights is just a variable. So weights is basically our weight file. So here, what is our weights file name? This is what our weights file name. As you can see, we have this one. Okay, so right click, rename, and just copy the name. Copy it, Thony Python ID, and here we want to mention that file name. So delete and Ctrl+V, just paste. That's it. Then config file YOLO4 tiny custom CFG. We have already the file inside our, as you can see, YOLO4 tiny custom.cfg. So we have our file already inside YOLO4 tiny rpi4 YOLO4 tiny custom CFG. Okay, then we have obj.names. Okay, so if I open again our repository, then we have here obj.names. Okay, simple. So we need to simply mention our weight file name. That's it. So I have mentioned it. Okay, as you can see, that's it. Now then config is equal to our custom config file cfg, then labels is equal to our obj.names, then count is equal to 0. Okay, then while loop, then rate emg cap.read. This is how we always call our camera. Okay, a cap. Then count plus 1 is equal to 1. Why? Because I'm going to skip here a 10 frames. Okay, because we are working on Raspberry Pi 4 CPU version, so we are going to skip some frames. Okay, for fastest detection with YOLO4 tiny version. Okay, so for that I have mentioned here count is equal to 0, then it will skip 10 frames. Simple. Then we are going to resize our frame. 680 is the width and 460 is the height. Then YOLO is the variable. Okay, so YOLO is basically our YOLO module. Okay, so as you can see, I have called here YOLO. Then inside that we need to mention our weights variable, then config variable, and then labels variable. As you can see, weights, config, and label. Then we will have here bbox, label, and conf. So bbox, label, and conf is equal to YOLO.detect objects. Okay, our method. Okay, YOLO.detect objects. Then inside that we need to pass our img. okay. Then cv2.im show img is equal to img, okay. And then what will be happen? It will basically show us a detection, okay. So simple. So if I save the code, if I run the code, and friends, as you can see right now there is no mask and it says without mask, okay. So if I wear the mask, and as you can see it says with mask, okay, with mask, okay. So we have here our Arduino board also. So as you can see without mask also it's detected our Arduino board, okay. Now we have here Pico board. So if I show Pico board, as you can see it's detected without mask fix and Pico board also, as you can see. So we have successfully create our own custom model for YOLO4 Tiny, and we detect our custom objects, okay. So I hope you will learn something from this video, okay. So I have shared the code, okay. So we will meet our next video. Till then, thank you, take care, and bye bye.